Okay, so on this warm-up, first true-false question, DC is parallel to AB. Were we given any information on that figure to say that those two sides are parallel? Nope, so this would be false. Number 2, the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D is equal to 360 degrees. Is that true or false? That is true. This right here is the sum of the interior angles. And for the sum of the interior angles of a figure, we do the number of sides minus 2 times 180 degrees. Well, 4 minus 2 is 2, and 2 times 180 is equal to 360 degrees. So any kind of quadrilateral, any kind of four-sided figure, the sum of those angles on the inside is 360 degrees. All right, number 3, segment AD is congruent to segment BC. Did they give us any information about those two being congruent? Then we would have to say false to this. Number 4, we have to do a little bit of supposing here. It says that if DC is parallel to AB, DC is parallel to AB, and AD is parallel to BC, so even though it doesn't look it on the picture, we're supposing that this is true. If those two pairs of opposite sides are are parallel, does that mean that they would have to be congruent? Yes, that is true. These two pieces right here are the definition of a parallelogram. And if the quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. Very nice work on the warm-up. We are going to be in your notes today, page 7 in your notes. Last week we talked about parallelograms and then rectangles. Today we're going to talk about 2 more shapes. So a recommendation that I want to give at this point right here, we are about halfway through this module. We've talked about 2 types of quadrilaterals. We're going to add 2 more today, and on Wednesday we'll add 2 more. So what I would highly recommend, if you want to make sure that you are prepared for the test next Wednesday, I would start making flashcards with the properties of the different shapes we've talked about. So I'd have a flashcard for parallelograms. I would have a flashcard for rectangles. Today we're adding 2 more. We're adding the rhombus and the square to this, so I would have a flashcard for rhombus and a flashcard for square. So a rhombus is a special type of parallelogram, just like a rectangle is. With a rectangle, it was a parallelogram with 4 right angles. A rhombus is a parallelogram with all 4 sides congruent. So that's the first thing I'm going to write for the properties on sides for our rhombus. All 4 sides are congruent. I'm going to go ahead and mark that on my figure. All four sides are congruent. Because this is a special type of parallelogram, that means that both pairs of opposite sides are parallel. So in addition to all four sides being congruent, the top is parallel to the bottom, and the left side is parallel to the right side. Just like a parallelogram, the diagonals bisect each other. And they are perpendicular to each other, which means they form right angles. So I'm going to go ahead and draw in my diagonals here. So because this is a special type of parallelogram, the two halves of my diagonals are congruent to each other. And because it's a rhombus, every single angle in here at the center where those diagonals meet is a right angle. So all four of those angles in there are right angles. So when we had rectangles, the diagonals were congruent. That meant these formed isosceles triangles. Because my diagonals are perpendicular to each other, it forms right triangles. So we can see all those properties of parallelograms coming out here. Both pairs of opposite sides are parallel, just like a parallelogram. Diagonals bisect each other, just like a parallelogram. And then we get into our angles. Just like a parallelogram, both pairs of opposite angles are congruent. And they're being bisected by the diagonals. So we see all those properties of parallelograms coming into play. And then we have additional properties that are unique to a rhombus. So let's come in here and mark these angle congruences. So in the lower left, This angle down here is being cut into two congruent angles. And then in the upper right, that angle is being cut into two congruent angles, and they are the same size as the lower left angles. The upper left is being cut into two congruent angles, and the lower right is also being cut into two congruent angles that are the same size as the upper left, because remember, my opposite angles are congruent to each other. So all the properties of a parallelogram with three additional properties. All four sides are congruent. The diagonals make right angles where they cross each other. And my corners of my rhombus are being bisected by those diagonals. So those are our properties of a rhombus. A square is a parallelogram with all sides congruent and four right angles. So squares are kind of a mashup of three different shapes. It's a special type of parallelogram. All four sides being congruent, that's just like a rhombus. And then four right angles is just like a rectangle. So it's going to have all the properties of a parallelogram, it's going to have all the properties of a rhombus, and it's going to have all the properties of a rectangle. So for my sides, all four sides are congruent. And both pairs of opposite sides are parallel. So I'm going to mark that just like a rhombus. All four sides are congruent to each other. And my opposite sides, left and right, are parallel. Top and bottom are parallel. So just like a rhombus, just like a parallelogram. The diagonals are congruent, and they bisect each other, and they're perpendicular. I'm going to go ahead and draw in those diagonals here, connecting my opposite corners. So they bisect each other and they're congruent. So that means all four half diagonals in my square are the same size as each other. And where they meet, it is forming right angles. So diagonals congruent, just like a rectangle. They bisect each other, just like a parallelogram. And they are perpendicular to each other, just like a rhombus. And then the last thing we need to talk about is the angles. They have 4 right angles, just like a rectangle. And they are bisected by the diagonals. So every corner in our square is a right angle. And each half angle in the corners are 45 degrees, because that is half of 90. So 4 right angles, just like a rectangle. And bisected by the diagonals, just like a rhombus. A square is both a rectangle and a rhombus. There's one last thing that I want to draw your attention to before we go and start looking at some problems. And that is right here. Looking at this small triangle, and I could look at any 4 of them. I'm just going to look at the bottom one. All 4 are exactly the same. We have a 45, 45, 90 triangle down here. Which is the same thing as an isosceles right triangle. Because we have a right angle here at the center, and then 45-degree angles in those 2 bottom corners. So if you know the properties of a parallelogram, the properties of a rectangle, and the properties of a rhombus, a square has the properties of all 3 of those shapes. Let's go ahead and look at example number 3 together. In example number 3, they tell me that segment LM is 2x minus 9. And they tell me that segment KN is x plus 15. It says that KLMN is a rhombus. What do we know about the sides of a rhombus? All sides are congruent. So LK is congruent to LM, is congruent to MN, is congruent to KN. So LM and KN are congruent, which means their measurements are equal. So LM is 2x minus 9. KN is x plus 15. And we want to solve this for x. So I get my variables to the same side first by subtracting x from both sides. 2x minus x would give me x. So x minus 9 equals 15. And then I would add 9 to both sides. And that means that x is how big? How big is how big is x? (24). 15 plus 9 gives me 24. Let's do number 4 and then we'll call it a day. I need you to sit up, dear. For number 4, we are told that this quadrilateral, WXYZ, is a rhombus. So you guys just told me a moment ago that means all 4 sides are congruent. What do we know about the diagonals in a rhombus? They're being bisected. They're bisecting each other. So AZ would be congruent to AX. And WA would be congruent to YA. What's happening here where A is, where those 2 diagonals are crossing? Forming all 4 right angles there. At the center we have 4 right angles. And then what do we know about down here at like angle Z or angle Y? What's happening there with the diagonals and the angle? What's happening here with these 2 angles? Yes. And then what's happening with this piece that's coming into that angle? It's bisecting it. So here, the 2 halves of Z are congruent, and they would also be congruent to the 2 halves of X. The 2 halves of angle W are congruent to each other, and they would be congruent to the 2 halves of angle Y. All right, and then let's take the information that they've given us and add it to the picture. It says AZ is 14. So here's AZ. That segment is 14. It tells me that ZY is 22. Down here is ZY. And then the last thing that it tells me is that the measurement of angle WYZ is 35 degrees. So WYZ, this angle right here. Sorry, I did WYX. WYZ goes the other way. WYZ, here we go. That is 35 degrees. All right, let's see if we can find any of the measurements down below. First thing they want me to find is XZ. How would I find the length of XZ right here? Multiply 2 times 14, yes. XZ is equal to 2 times AZ, because AZ is half of that diagonal, and the diagonal is being bisected. So XZ is 2 times 14. So how big is XZ? 28. All right, that's one thing they asked me for. The measurement of angle XYZ. Angle XYZ. This whole angle down here by Y. How would I find that? Yes. Absolutely correct. Measurement of angle XYZ is 2 times the measurement of angle WYZ. Angle WYZ is 35 degrees, so we do 2 times 35 degrees. And that would give us what? 70 degrees. All right, we've got one more piece that we need to find. We want the measurement of angle WXZ. WXZ. We're looking for this little piece right here. Well, if I could figure out how big that whole angle is, WXY, then I could just take it and cut it in half. To find the measurement of angle WXY, we do measurement of angle WXY plus the measurement of angle XYZ. Those are consecutive angles, so they would add up to 180 degrees. Well, we know that XYZ is 70 degrees. We just found that a moment ago. So WXY plus 70 equals 180. So I'm going to subtract 70 from both sides. What is 180 minus 70? What is 180 minus 70? 110. And then the measurement of angle WXZ is equal to half of the measurement of angle WXY. So we need half of 110 degrees, which would give us what? What is half of 110? I'll go back. I just need this answer first, and then I'll go back and explain anything you need to see. 55 degrees. Okay. So here's what happened. WXY, this whole angle up here, plus this whole angle down here, is 180 because they're consecutive angles. We didn't want this whole angle up here. We wanted just this piece of it. And that angle is being bisected by this diagonal. So we found the whole thing, that's the 110, and then we cut it in half to find WXZ, this piece right here. Does that make sense? Yes. Because this whole angle right here is 110 degrees. And then we cut that in half to get our 55 degrees here. All right, the homework that you guys grabbed on your way in the door today, that is due on Wednesday. Yep, I'll go right back. Homework is due on Wednesday, and the test is a week from Wednesday. Homework 5 is due on Wednesday. Test is a week from Wednesday. in the wire tray. Homework needs to go in the wire tray on your way out the door. Yes, absolutely. Good. Okay. You're welcome.